Hello, today we're going to be taking a look at a bunch of different intake designs for PC fans to see if it improves fan efficiency, airflow, and airspeed to make the most efficient, intake for your PC case as possible. I hope you'll join me on this scientific adventure. These are all the 120 up to 140 millimeter size fans, meaning that the outer rim of the intake area is 140 millimeters, and they are all individually labeled and named for their different size and capacity, or I should say design scenario. I'm going to have a geometry cross-section here in a little bit so that you can really delve into what it looks like, but this is the first set of intakes. All right, this is the second set of intakes. These are substantially larger, 160s and 180s and 200 millimeter down to 120. So some of them have different radii for the curvature going in, as well as different vertical height for how quickly it basically flows into the main fan area. All in all, I tested at least 12 different fan intake designs to see which one will be the most efficient. Now let's get into the geometry of each of these intakes. Before we get into the fans, I want to show off the different geometries of the intakes, as well as the names that are going to be on each of the graphs as we move forward. So you can see the curvature on it, the vertical height that it had. Remember, these are not proportional to each other because I just want to fit as many on here as possible for picturing surface possibility. And I just took a vertical cut in CAD software to create the view that you're seeing on the screen. And then here's the second set of images. So the largest size was 200 millimeter, and even the smallest size of the intake was 140 millimeters, and then I adjusted the vertical height and the geometry of the curve for various applications. So I have the fan running at 3 different RPMs, so 50, I think 80 and 100%, and just kind of pick them arbitrarily to try to have how different, basically suction, so how much airflow is going to flow through it, to see if there's a geometry that works the best versus at each RPM, or kind of vice versa. So on here, you can clearly see that the 25 millimeter thick 140 R18 works the best, and the 25 millimeter thick 140 straight also works the best. They are basically tied, moving up to 100, or not 100, 80% RPM. The straight is also still ranked first, while we have a new also first at 35 millimeters thick, 200 millimeter. So that's kind of the largest diameter for that intake area. And then we have 100% pitot and fan signal, and we have a new first place, the Gravity Well 2, while the other ones tend to outperform my control fan without any intake on it whatsoever. Well, I was kind of baffled by this data that there really wasn't that much improvement. Keep in mind that the horizontal axis isn't from 0 to whatever the airspeed is. It is from a designated point. So in this graph's form, positioning 1.2 meters per second to 5. So just the fan without any intake blows at 1.3. With the best, it blows at 1.5 with a filter on it. So there's an improvement there over baseline, but how much improvement are you getting over other ones? 0.1 meter per second. So it's kind of interesting with regard to that. So moving up to 80%, you can see which ones kind of fall away a little bit, but there's always improvement. And then at 100%, all right, and then because I was kind of blown away by how little effect that this intake had on the fan's performance, I decided to get out my 3000 RPM Superflower Mega Cool and rerun the tests just to allow for maximum intake, maximum airflow that I had at hand when I was doing this testing. And the Superflower is baseline right here without any intake on it. And so you can see which ones are the very best. The Gravity Well 2, Gravity Well, and the 35 millimeter thick 180 all were ranked really, really, really high. So now which design is actually actually the best? So using math, I did percent difference versus the fan without the intake on it. So right there. So filter and no filter. So right and left side. So let's focus on no filter first. So the best overall in the tests for the A12X25 for 50, 80, and 100% is the 25 millimeter thick 140 straight. In second place, it looks like it's the 25mm thick 140 to 120 R18. And then right in line with that, a little bit below it, is the Gravity Well 25mm thick. While with a filter, it changes up positioning. You have the 20mm thick 160, and you can kind of see the other ones and how they rank. And for the 3000 RPM beast of the Superflower, the percent difference, the very best appears to be the Gravity Well 2, followed by the Gravity Well, and the 35mm thick 180 down to 120. So depending on how much airflow your fan is sucking in, it varies which one is the actual best, which does kind of make sense. You would design the inlet for the optimal speed that you plan on it running at. But I was surprised that it kind of varied in swings and how little it actually affected the fan itself. I would have thought that having an intake on it would have had more of an effect. I was expecting not 1 meter a second, but I was expecting like 0.5, not just like 0.2 as the maximum. So again, this is percent difference, not value difference. Okay, here's the raw data. The raw data, whatever. It does belong to this channel because I generated it, but it took a surprisingly long amount of time to do the testing because, I was just running things and I was like, well, I might as well do the filter because the data is kind of weird for me. So here are the fans. Here's the different pitot fan signals and how much airflow. So what does this mean? Should you go slapping an intake on your computer fan? In most cases, absolutely not. It doesn't really improve airflow. What's the conclusion? Should you put a intake over your fan? Again, not really. Was this a waste of time? Not really. The data was fun and it was cool to make the different geometries in CAD and then print them all out. I made the infill really, really sparse, so I was using as little material as possible. And now I have all these intakes that I have no idea what to do with. Maybe I'll have to run some other types of experiments and see what kind of crazy things I can do with it. Anyways, thank you for watching. If you like what I'm doing with this channel, please think about joining me as a Patreon or YouTube member. It's that allows me to purchase materials to make stuff for this channel. If you don't want to subscribe, please drop me a super. That helps too. Or not subscribe, become a member or Patreon. And please think about subscribing because that just helps this channel gain traction. Anyways, thank you. I'll see you next time here on Computer Tech and More.